Hello. So the purpose of this video is to help with the understanding of exactly what it is that we do with class design, inheritance design, interfaces, etc. when it comes to object-oriented programming in general. Now, if you are having trouble with the technicalities, with the syntax of writing classes and objects and such, refer to the W3 School web pages, refer back to the original videos on the topic. Both of those contain all of the technical knowledge that you need for actually writing the code. There's going to be no code in this video. It is strictly analog examples to help better understand exactly what the thought process is for doing object-oriented programming. Let's start off with basics. We have data. In this case, text data. And you can sort of think of this index card as a variable. I can do things with it. I can perform operations with this. I can store it someplace. So I could put it over there to store it. I can retrieve it. If I wanted to, I could destroy it. There's only so much I can really do with that bit of data. Yeah, it's a variable. What if I want to have lots and lots and lots and lots and lots of text data? Like a whole bunch of text data. So much text data. So much text data. I'd have a book, right? And this is a perfect example of an object or a class in programming. It has primitive data types inside of it. It's got words, text data, but there are specific operations that I want to be able to do with this. The book is currently closed. I can open the book to a random page. I can turn pages forward. I can turn pages backwards. I can close the book. It's a nice little contained bundle of data, so I can put the book, well, can't really put the book right there because it won't fit. But you get the idea. It's like there's a bundle of operations that I can do with this book, with this class. But there's different types of books, right? So we've got ye old standard paperback. We have a hardback rule book. Can't bend it because it's hard. It's got a hard cardboard. I got a hardback sword book that's mostly non-fictional. It's, again, drawings on actual swords. I have a paperback rule book that has full color plates in it. So we've got all these different types of books, and this is where inheritance comes into play. Initially, I might start with just a very generic concept of a book. And I know the book's going to have pages. It's going to have to be able to open. I'm going to have to be able to close it, turn pages forward, turn pages backwards. And it's like at a minimum, it's like that's what I'm going to need to have for a book. It doesn't matter what type of book it is. It doesn't matter if it's really big, like this one. It doesn't matter if it's kind of small, like this one. Still a book, even though it's itty bitty compared to everything else. So independent of those things, it's like I know there's like just certain definitions, right? It's like I've got a fixed number of pages, and I've got those operations. So I might create what's called an abstract class based on just this generic concept of a book. And then I can make more detailed objects. So this I would call a paperback. So this paperback book would be a child of book. So this would inherit from book because it's got all the things a book has, right? It has a fixed number of pages and it's got the book operations. I can open it, I can close it, I can turn pages forward, I can turn pages backwards. It has all the methods and functionality of a book. But it's got certain additional pieces of information. For example, it has dimensions. It has like a cover. It has black and white text in it. It has page numbers. And so I might want to get a little bit more defined with this. But in general, this would also be a paperback, right? It's got, this is the part that can trip a lot of people up. From a modeling point of view, these two things are almost identical. I mean, obviously to us as humans, they're not, right? Like this is a fantasy paperback. This is a rule book. They're not the same. But from a modeling perspective, they are. They're both books. They both have a fixed number of pages. They are both floppy. Well, this one's more floppy than Silmarillion is. This guy's a chunky book. But again, they're mostly the same, right? They have pages. I can open them, turn forward, turn backwards, close. They've got covers. And so they could both be paperback books. What about the hardbacks? Again, a hardback would be its own class. This would still be a child of book. Because again, to drive the point home, this has all the properties of a book. It has a fixed number of pages. Contains primarily text data. I can open it, close it, turn forward, turn backwards. All of the methods that work for book work for this. But again, it's got some of its own things. It's like it's got a hard cover. It cannot bend. This was a little bit same thing for this one. It's like, yes, the contents of these two books are radically different, especially when you consider that, again, this one has as much, if not more, artwork than it does words. Something else this one has that the other one doesn't. It's got a slipcover on it. If I take the slipcover off, it's still a book. But do I need an entire separate class? Do I need a class of hardback book with slipcover and hardback book without slipcover? Probably not. This would be an example of a container or composition, actually I should say. I could have a slipcover class. And then any hardback book is going to have a reference to a slipcover. This one would have a reference, would actually have that reference be not null. This one's reference to a slipcover would be null. It does not have one. It has never had one. Now, as to why I have this in view, this is my library. It is literally what this type of furniture is called. It's a library. And while it's related to books, it is not a book. This would not inherit from book. This is a library. It might inherit from furniture, you know, if I had an abstract furniture class, but this is going to be the library class. Now, it is going to have a reference to books. This is a perfect example of the has-a relationship. A library has books. A paperback is a book. That is the difference between an is a has a relationship. This is a book. This has books. But this is still a good example of a class. The library has data. In this case, the library's data are shelves. How many shelves does it have? What is its volume? How many books can it contain? And of course, it's going to have operations. I can pull a book out. I can put a book in. And if I had the doors on this right now, there would be further operations there. I could open a door to access a specific area, and I could close the door, protect it from dust. So the library has books, but is not a book. So this is, when you're trying to model things, this is kind of what you need to be thinking about. What are the relationships between the things I am trying to model? Now, what exactly is it that I need to model about a book? And how do I want to differentiate this from this? Is it important? Probably, because where you can put certain types of books is going to be impacted by not only their size, but how rigid are they. But that's not the only thing, right? So we've got inheritance, abstract general concept of a book, paper book, or paperback, hardback. But then we also have interfaces. So not every book is going to have the same thing. For example, the Silmarillion has an index of names, a sizable index of names. Wasn't exaggerating. And it also has an appendix that defines terms. This does not. It's got some maps on its final page, an advertisement, then that's it. There's no index, there's no appendices. This has a bibliography. Look at the final page. We've got a bibliography and sources and inspirations. Whereas this one has reference charts. Now, you could make an argument of, okay, yes, well, that's just part of the data of the book. But I could also make an argument for those are interfaces. Because remember, interfaces define what functionality must exist, but not how that functionality is implemented. So, not every book needs to have an appendix where you can look up terms. Again, like I said, this one does not. If I want to look up the definition of a term in this book, well, I'm just going to have to read the whole book to find it. Whereas in this one, I don't have to do that. And in more reference-oriented books, they will even tell you the pages in where those terms appear. So I can go and look up the specific pages where those terms are. This does not have that. It just simply tells you, here's the terms and definitions, no page numbers. So how things can implement an appendix or an index can be different. These are good examples of interfaces. This book implements the appendix interface. So does, well, I can't reach it because I forgot to grab it, but so does most of my programming books. Oh, hold on, that's right, down here. So I have an index that tells me terms, well, an index, not an appendix. So yeah, so this has an index that gives me page numbers. And I have seen appendices that also have page numbers on them. So different books are going to implement different search features. Practically every book has a table of contents. That doesn't mean every book does. I would argue that it's a bad book if it doesn't have a table of contents, but that's besides the point. There's no rule that says it has to have one. So this is the general idea behind interfaces. It's functionality that might be implemented, but then again, it might not be implemented. Not every book is going to have an index or an appendix or charts. And so these are the types of things that would work well conceptually as interfaces. This implements the appendix interface. This implements the bibliography interface. This implements the reference chart interface. And then this one doesn't implement any of those interfaces. It does implement the table of contents interface, as do all the others, but it doesn't have any of the index, appendix, bibliography, or anything else like that. And so when you are looking at class design, when you're looking at object design, trying to figure out what should this model, you have to both take into consideration what kind of data am I looking at, and how do I want to separate out that data? Like for creating subclasses, I would not want to create a fantasy softback class that inherits from book and a rule book softback book that inherits from book. I wouldn't want to do that because the fact that this contains game rules and this is a fictional history, not sure I necessarily want to call it a story. Fictional history is better. Is sort of irrelevant to their design, to me modeling them in a program. They're both books. Now, the thing that I might want to model different is the fact that other than the cover, this is a black and white affair. There is no color in this. The cover has color, but that's it, which is standard for paperbacks. Whereas this has, as I've shown before, it has full color plates in it, in addition to having these, where is it? These blue borders and blue text. And then I have other books. Pull this one out. That are almost entirely art. I mean, this is still a softback book with a sheet of paper in it, apparently. Still a softback book. But I might, again, depending on how I'm modeling things, I might actually want to have like an art book separate as its own class. And again, that inherits from books, so this is still a child book. It is a book. Versus a paperback novel. And again, I wouldn't want to do fantasy novel, mystery novel, sci-fi novel. It would just be paperback novel. Likewise, you know, this and a hardback novel are significantly different. So again, it might be worthwhile to model hardback novel versus hardback book. And that's where the tricky part of object development and where programming comes into play, is trying to figure out exactly how you want to model things. There is unfortunately no easy answer, no easy solution to that, other than just sitting down, thinking it out, drawing out diagrams, bouncing ideas off of people. If you've got a client, once you've got everything modeled out, showing it to that client and saying, hey, this is how I intend to model the environment. Does this meet your needs? But again, just to recap quickly, we have the generic concept of a book. We have a paperback, which is a book. It inherits from book. It is a child of book. We have hardback, which is a child of book. It is a book. The hardback will contain a reference to a slipcover. Which could be null, because not every book has a hard slipcover. And then as a better example of the has a relationship, we have the library class. It has its own data and operations. It has shelves. It has fixed amount of storage for books. It has the ability to open and close doors, take a book out, put a book back in. And of course, it has books. This is the has a relationship. The library has a book. The paperback is a book. Again, hopefully this helps clear up some misunderstandings on what exactly object-oriented programming is and what the focus on it is. Again, if you are having technical issues with the syntax, go back and reread the W3 School pages, go back and rewatch the original videos, because those will cover, that will definitely cover all of the technical requirements. And hopefully this helped with the more soft understanding. Until next time.